Iron in the asteroid 16 Psyche is said to be valued at 8,973 quadrillion euros, where 1 quadrillion equals 10 to the 15th power. So 1a, write down the value of the iron in the form of A times 10 to the k, where A is greater than or equal to 1 and less than 10, and k is an integer. Well, the first step is just to write that from what we know already. That's 8,973. Quadrillion euro is 10 to the 15. So 8,973 by 10 to the 15. Okay, the problem is we can't leave it like this because A, which is that constant there, that's that one, it has to be less than 10 and greater than or equal to 1. So we have to choose 8.973. We're going to put the dot here, the period. So it's 8.973. If we change that 8,000 to 8.9, we've reduced it by 1,000. So we've got to increase this number here by 3 zeros to 18. It becomes 8.973 by 10 to the 18. Therefore, the value of iron is 8.97 times 10 to the 18 euros to 3 significant figures. James believes the asteroid is approximately spherical with radius 113 kilometres. He uses this information to estimate its volume. Calculate James's estimate of its volume in kilometres cubed. Well, all we need to do is get the volume of a sphere formula from the formula booklet and substitute R equals 113. And we get this number here, which is 604,3992.82012, or 6.04 times 10 to the 6 kilometres cubed to 3 significant figures. This question is percentage error, so we've got this from the formula booklet. The actual volume of the asteroid is found to be 6.074 times 10 to the 6 kilometres cubed. Find the percentage error in James's estimate of the volume. James's estimate was the part B, 1B. That's the previous question. We've got to be very careful with it here because in the question they're using the word actual, but in the formula booklet, the A doesn't stand for actual, it stands for approximate. So have a look what I've done here. I've copied from what I've got in the question, what we have in the question. The actual is that's here. The estimate is from the previous page, and we're not using our 3 significant figures. We're using as much data as we have, which is all of that to get for accuracy. But see what I've done? This is V actual in this part of in the worded question, but in the formula booklet, V actual is not VA, it's actually VE. So be very careful there because E means exact. So actual means exact in the formula. And estimate, there's the E, but it's actually VA. So be very careful with that, the way we use this. Make sure you always double check what the VE is and the VA is. What you'll find is in this formula, if you just keep in mind that the exact value, the true value is always going to be on the bottom. Okay, that'll help. So the percentage error is that formula right there, and we just filled it all in. Don't forget to times it by 100%, and you get 0.494% to 3 significant figures. And just one other thing, these lines here means that your answer has to be positive. If all of this becomes a negative number, you've got to leave it as a positive number. You cannot have a negative number when you're doing percentage error. It always has to be positive. Okay, this is all about a speaker. This company is designing a portable Bluetooth speaker. The speaker is in the shape of a cylinder with a hemisphere at each end of the cylinder. That's the shape. You see these often in shops. So there it is as a line drawing. The dimensions of the speaker in centimetres are illustrated in the following diagram, where R is the radius of the hemisphere. Hemisphere just means half a sphere, right? And L is the length of the cylinder, with R greater than 0 and L greater than or equal to 0. So that's the length, and that's R. All right. Okay, so 2A, write down an expression for the volume of the speaker in terms of R, L, and pi. Well, that's what we have. We've got R, we've got L here, and pi, of course. Now, I've broken it up into 1, 2, and 3. It's a good idea just to break it up. And so 1 and 3. Now, 1 and 3, if you put them together, would be one sphere. So 1 is a hemisphere. That's also a hemisphere. It's got the same radius. So you put those together, you'd get one sphere. So I'm going to put them together at the beginning and say, well, I'm just going to calculate the volume of a sphere with that radius because I've got the two halves. So the volume of 1 plus 3 is 4 on 3 pi r cubed. Now, that comes from the formula booklet. The volume of the second one is the volume of a cylinder. Well, the volume of the cylinder is the area times the length, the cross-sectional area, right? So it's pi r squared times L. So the total volume is this number here plus this number here. Well, I simplified it a bit, but actually that's good enough for the answer. Okay, same question. We've got 2b now. The company has decided that the speaker will have a surface area of 300 centimetres squared. So that's decided. Write down an equation for the surface area of the speaker in terms of r, L, and pi. Okay, so what we've got to do first is just write down an equation for the surface area of the speaker. Now we're talking surface area here. Surface area of a sphere comes from the formula booklet here. It's 4 pi r squared. So again, I've just put 1 and 3 together because I'm going to consider the two hemispheres as one sphere. So I'm going to work out that one. So the surface area of 1 and 3 is just the surface area of a sphere with a radius of r. So that's 4 pi r squared. The surface area of 2, if you remember, this is not in the formula booklet. You need to remember this. The surface area of an open cylinder, but we're not considering the ends. And the way you think about it is if you unwrap the curved surface and flatten it out, it becomes a rectangle with the length and the height used to be the circumference of the circle, the cylinder, which is 2 pi r. So it's 2 pi rl, 2 pi rl. Therefore, the surface area of the speaker, the whole speaker, is our 4 pi r squared, which is the surface area of these two hemispheres, plus the surface area of the cylinder, the curved surface of the cylinder. Remember, it's open-ended, so it's just a curved surface, and that's 2 pi rl. So that's it there, and I've simplified it a little bit. Now, for 2c, it says, given the design constraint, basically they're just saying that this is the relationship between L and R, and it's to do with the design of it, right? So that's just decided. They tell you that. Show that V equals 150R minus 2 pi r cubed on 3. Well, the first thing you notice is on the left-hand side is V, and on the right-hand side is only R. If you go back to 2a, we determined this. That was the solution to 2a. And we have V on the left-hand side, which they want. But look, they've got R's here, and we've got an R and an L. But they've just told us that L equals that. So we replace L. When L equals all of that, we just put all of that in for L and do the algebra, and we come down to 150R minus 2 pi r cubed on 3, which is what they wanted us to show. Okay, 2D was find dVdr. We can do that now because we've got V in terms of R, and that's from the previous question, right? And so dVdr, okay, you're taking the derivative, and remember the derivative is, if that's 150R, then the derivative is you bring down the number that's there, which is effectively a 1. So the 1 comes down and multiplies by the 150, and that's 150. And then it was a 1, so you take away a 1 and it becomes a 0, and so r to the 0 is 1. So that became this constant 150. Here, 2 pi on 3 is actually a constant, so I took it out of it just so we can focus on the r cubed. Because remember, it's dVdr. We're only interested in the r. So we bring the 3 down to the front, and that's what I did here. And then 3 minus 1 is 2. And so that there is the derivative of r cubed. And then we resolve that up to 150 minus 2 pi r squared. The quality of sound from the speaker will improve as V increases. So as the volume increases, the sound is better. That's what it's saying. So 2e, using your answer to part D, show that V is a maximum when R is equal to the square root of all of 75 on pi. So V is at a maximum when the derivative equals 0. If you think about the curve, remember, the maximum and minimum points are indicated by a slope of 0, a 0 slope. And since the derivative represents the slope, or the gradient, then the dVdr equals 0 for a maximum. Now, how do we know it's a maximum? We know it's a maximum because we got this. We know that dVdr equals 150 minus 2 pi r squared. Well, that's minus r squared, so we know it's an upside-down parabola. And all we have to do is equate that derivative to 0. And that's what we're doing here. And we resolve it up to find r, and we get r is the square root of 75 on pi centimeters. And that's what they wanted us to show. Yeah, show that. F, find the length of the cylinder for which V is a maximum. Well, if we want to find the length when V is a maximum, we know that V is a maximum at R equals the square root of 75 on pi. So all we have to do is go back to this formula that they gave us here, which they said that was a design constraint. And we put in R, basically we put in R. This is our relationship between L and R. So if the maximum volume occurs when R equals that. Then we want to find what L is at that maximum volume, so we put that in for R, and I've just substituted it in there and in there. And guess what, guys? It's 0. Calculate the maximum value of V. Well, again, we know that the maximum value of V occurs when R equals the square root of 75 on pi, so we just put that back into the original equation. This is not the derivative, right? This is our volume equals. This is our volume in terms of R. So we just substitute the square root of 75 on pi in for there, and we get 489 centimetres cubed to 3 significant figures. And the last question here, use your answer to part F to identify the shape of the speaker with the best quality of sound. Well, part F was this one here where they said find the length of the cylinder, and we found the length was 0. So basically in part F, we found out as far as the design or the shape of the speaker, when L is equal to 0, we get the maximum volume, and they said the maximum volume gives us the best sound. So therefore, when L equals 0, the shape is a sphere. Because, right, it's got no length, it's just two hemispheres together. Therefore, a sphere shape will give the best quality sound.